Alright everyone, as I told you that we are going to deal with exponential expressions. So I'm going to introduce some of the important laws that you need to know in order to solve an exponential expression. So the first law that we are going to deal with, let me write laws of exponents. So these are laws that you need to follow. The first one, it says that if you have a to the power n and then multiply by a to the power m, this law says that you keep only the base and add the exponents. That means you keep the base, only one base, and then you add m plus n. If you have the exponents of the same base, you keep the base and add those exponents. This is the first law that you need to know. And then the second one says that if you have a to the power m divided by a to the power n, that means you also keep one base and subtract those exponents when we deal with division. This is a numerator, which is a to the power m, and then we have the denominator, which is a to the power n. That means we keep only a base and we say m minus n. So that's the difference. If the base are the same, you keep the base and add the exponents. But if we have a division of the same base, that means we keep that base and subtract the exponents. And then the third one, here you must remember that this a must not be equals to what? 0. The denominator must not be equals to 0, because we're gonna get an answer which is undefined. And then we have the third law, which says if you have a multiplied by b inside the bracket and then we have an m as an exponent outside the bracket, that means this one will give you a to the power m and also b to the power m, provided that for this one, no. And then we have also the fourth law, which says that if you have a divided by b and then you have the exponents also outside the bracket, it means that you keep this one will give you a to the power m divided by b to the power m, provided that b is not equals to 0. This b is a denominator, so must not be equals to 0. And then the last one I'm going to introduce for this for today's lesson, it says that if you have a base a with exponent m and then multiply by n outside the bracket, you have the base a to the power m inside the bracket, and then also outside the bracket there is an exponent which is n. Therefore this means that you keep the base and multiply the exponents. That means the exponents which is m inside the bracket will be multiplied by the exponents outside the bracket, which is n. So we have law number 1, law number 2, law number 3, number 4, and 5. The first one says that if you have the exponents of the same base, you keep that base and add the exponents. If you divide the exponents also of the same base, you keep the base and subtract those exponents, provided that you must know this a must not be equals to 0. So if you multiply the exponents of if you multiply the bases which are not the same, like a multiplied by b, and then outside the bracket is an exponent m, that means this m will multiply the exponents which is 1 here. You must know if you have a number like a, there is an exponent 1, but we don't write it. And then m multiplied by the exponents which is m will give you a to the power m, multiplied by b multiplied with an exponent which is m, 1 multiplied by m will give you m. Therefore a to the power m multiplied by b to the power m, which this m multiplied by 1 of the inside exponents, inside the basis of the exponents which is 1. And then the fourth one says that if you divide the exponents, if you divide the bases which are not the same, and there is an exponent outside the bracket, which is m. That means there is 1 here and also there is 1 here as an exponent. Therefore, you multiply also the two, same as this one, but this one is a division. Therefore, you must know that this b must not be equals to 0. Because if this b is 0, we get an undefined. And then the fifth one says that if you have a base with an exponent inside the bracket, therefore outside the bracket there is an exponent also. That means you are going to multiply the exponent inside the bracket to the exponent outside the bracket. Alright. Let us take some of the examples from these laws. So we can take from number 1. Let's say we have 2 to the power 4 multiplied by 2 to the power 3, which means for this one 2 to the power 4 and 2 to the power 3, we have the same base, which is 2. Therefore, if we have the same base, which is 2, that means we're going to keep that base. If we keep that base, we have the exponent, which is 4 and 3. That means we're going to add these exponents. Remember, they are not inside the bracket. If you have the exponents of the same base, you keep the base and add those exponents. Therefore, we are going to get 2 to the power 7. That's the example from the first law. And then the second law, we have 2 to the power, or let us use another one, 3 to the power 2 divided by 3 to the power, alright, 3 to the power 2 divided by 3. We all know that when the number, this is a number, there's an exponent 1, but we don't write that exponent. Therefore, this one will say you keep the base and subtract what? These 2 exponents. That means it's 2 minus 1, which will give you also a 3. We know that if it's 3 squared is equals to 9, divided by 3 will give you 3 also. And then let us check the third one. The third one, it says that if you have a to the power 2 multiplied by b to the power 2, they are inside the bracket and there is an exponent 3 inside the bracket. That means for this one, we know that this 3 we multiply the exponent of a, which is the base a, to the power 2. Then we will also multiply the exponent of b, which is 2. Then here we are going to have a to the power 3 times 2, which is 6, multiplied by b to the power 6. The exponent outside the bracket multiply the 2 exponents of the 2 variables inside the bracket. Therefore, the fourth one that I have introduced is the one which says that if we have a to the power 2, a only, divided by b to the power 2. This is an example, and then we got 3 as an exponent outside the bracket. That means here there is 1, which means a to the power 1 multiplied by 3, which is the exponent 1. 3 times 1 will give you 3, divided by b, which is 3 multiplied by 2, that will give you 6. And then we have the fifth one. The fifth one was saying if you have, let's say, x inside the bracket to the power 4 multiplied by 3 outside the bracket. I said that according to this law, you have the base x to the power 4 and then multiplied by 3 outside the bracket. That means the exponent inside the bracket will be multiplied by the exponents outside the bracket, which means we keep the base, which is x. Therefore, we multiply the 2 exponents, which is 4 multiplied by 3. Therefore, we'll give you x to the power 12. I suppose you get that one. And then, what is also important when dealing with exponents is that if, let's say, you have an expression which is, say, negative 4a to the power 2, b to the power 3, they are all inside the bracket. And then you have the exponent 0 here. This law says that if you have a to the power 0, this is equals to 1. That means you can have so many variables inside the bracket, but if the power is 0, that exponent will be equals to 1. Alright. Let us take another example which involves the square root. That's another law which says that if you have x as a base, and then we have m divided by n. That means this exponent is a fraction. We know that when we talk about a fraction, we're talking about numbers like 1 over 2, 1 over 3, 3 over 4. Those are fractions. So we have the exponent, which is m divided by n. And you must know that here n must not also be equals to 0. The denominator of an exponent must not be equals to 0. So for this instant, when you introduce in a square root form, we say that you keep the base, which is x, and then the numerator of the exponent will be the exponent of the base. Therefore, you put a square root here, and then there is an n. That means it's an n root in x to the power m. Alright, now I'm going to give you some of the exercises that you need to do, and then after we are going to mark those expressions that I'm giving you now. So let's say you have 2 multiplied by b to the power 1 over 2. This is the first one. The second one is a multiplied by b to the power c. And then the third one is 1 over 2 to the power m. And then the fourth one is 2 to the power b multiplied by 2 to the power c divided by 2 to the power d with an exponent f. So try this example so that we can get to more complex equations that we need to follow. So remember, for this one, we have an exponent which is f. Therefore, there are also 2 bases inside the bracket, which are the numerators. So what we have to do first, we have to follow the first law, which says that if you have the exponents of the same base, you keep those exponents and you keep the base and add those exponents. So I'm going to give you time to solve this one, and then I'm going to do some of the important complex expressions that you need to solve. Thank you.